Hey guys, and welcome to another tutorial. I'm sorry it's been a while, but it's just the way it is. So, getting on with the tutorial. So today I'll be talking about the minimum spanning tree, and especially Prim's algorithm to solve the minimum spanning tree. So, Prim's algorithm is a greedy algorithm, and there are other algorithms like Kruskal's, but I just chose Prim's algorithm for this example. So how Prim's works is I'm doing an undirected graph. So, but I believe you can do it with um, a directed graph also. It just might be a little bit different. How it works is you have some nodes. So, um, I'll keep it like this. So the red dots represent nodes or vertices on a graph, and what it does is, let's say that from here, let's push this in a different color, from here to here, there's an edge, from here to here, there's an edge, and from here to here, there's an edge. Let's have this edge have a weight of 2, this edge have a weight of 3, and this edge have a weight of, let's keep it 4, just for a little bit more simplicity. So what we have is a graph, and it's undirected, so it means you can go both ways from each node. And how prims work is we pick a starting node. So let's let this be our starting node right here, and we start on this node, and we look at all its children, all the nodes it is connected to. So it is connected to these two nodes right here. And now what it does is it looks at its connected nodes, and it picks the minimum distance of all the children's weight, the edge's weights. So in this case, 2 is less than 3, so it'll draw a connection to 2. To this node. So let's draw that right here. Okay, so now these, actually let me label these. Let's have this as A, B, and C. So A, B are connected by an edge now. So now what the algorithm does is, now there's both A and B on that are connected together, and then it looks at all the unconnected nodes that still haven't been connected by any edges. So in this case, there's only C, and then what it does is it runs through all the connected nodes and picks the shortest distance between a node and any other unconnected node. To rephrase that, it picks the shortest distance from any connected node to any unconnected node. So it'll first check A's distance with C, because C is the only unconnected node remaining, and that's 3, and then B's distance to C, and that's 4. So it'll pick A to C because it has a weight of 3, which is less than B to C's connection, which is a weight of 4. So to recap this, well, now we have created a minimum spanning tree. This is the minimum sum of the weights to connect all the nodes. So to recap the minimum spanning tree, and especially Prim's algorithm, what it does, it has a starting node. From that starting node, it then picks the it picks a node with the least edge, So, and then the algorithm then cycles through all the connected nodes and then finds the shortest edge to an unconnected node and keeps on finding all the shortest edges until there are no more unconnected nodes and all the nodes have been connected, and then the algorithm stops in the code. would stop trying to find the paths, and then you are then left with a minimum spanning tree. So what I did was I first wrote this code in Python, and it worked, and then I wanted something a little bit more interactive aspect to it. So I knew processing from a while back, and something new had come out as a branch of processing, and that was called P5JS. Now, P5JS is kind of a more web-based version of processing. It still has all the capabilities processing can do, like accessing camera and all that things, but it now has that web aspect to it, so you can actually kind of upload your code to a web server, and people can access your code through the internet, which is kind of cool. So what I did was I just referenced this language and picked it up. It's fairly easy to pick up. So let me explain my code. Now, since it's a little bit different in this scenario, because all you do is draw the nodes, and in real time it'll calculate the minimum spanning tree. So there's no already pre-connected edges, but instead imagine that you can access from any node any other node. So to draw that out, imagine that we have a bunch of these nodes that you have just plotted down with your mouse by clicking on the screen. Now, these nodes, you are not drawing any edges between them, no connections between them. And instead, what happens is that the code kind of thinks that from this starting node, if this is the starting node, then this node can reach all the other nodes. And how the weight of the edge is calculated is the pixel distance from each node. So by pixel distance, I mean when you click your mouse, I read the x and y coordinate on the grid and then store that to the node's value. So for each node, I know its x and y coordinate, and then I can calculate the distance from that, and that distance is, think of it as the weight of the vertice. So from this starting node, I can equally access all the other nodes. So for example, it looks like this node is slightly shorter, so it'll connect to here, and then pardon my friend's notifications, it'll connect to this node over here, and then what it'll do is between these two nodes, which node is then the closest. So it looks like this node is then the next closest one, and then, sorry, I'm just doing this by rough estimate, then this node looks the closest, and this node looks the closest, and then there's still some unreached nodes, so from here it'll be here, then from here I think it's gonna be like this. Sorry, so it's a little bit different on like a Euclidean, like a Cartesian grid, but you can still apply the same algorithm, just instead of the weight of the vertices, just the distance between the coordinates, and there's no predefined vertices between the nodes. Each node can equally access any other node. So coming back to my code, what I explained there is what my code does. So let me give a quick rundown of my code. So in my setup, all I do is I make the canvas so it fits the whole screen. It's the playable space that I can draw on, write on, like take the mouse's values from. And then before that, I have this array or list called vertices. What vertices does is just contains all the click nodes. Okay, Cloud9 is slightly glitching. Okay, and then so now function mouse pressed does is whenever a mouse is pressed, this function gets called whenever you click your mouse, and then what it does is it refreshes the background, and then it adds that node's mouse x value and its mouse y value to the vertice or list, and then for every vertice there is in the list, it'll redraw all the nodes. So the reason why I'm redrawing all the nodes for each time the mouse is pressed is because each frame I keep on kind of clearing the background because I don't want any lines from the previous minimum spanning tree to be on the new updated minimum spanning tree. So I'm recalculating everything each time a new node is added. And then what I do is I call prims. Prims is a function. What prims does is it has two lists, one called unconnected, one called connected. And then for each of the unconnected lists, for each of the vertices, nodes in the vertices, it pushes that all to all the unconnected vertices. Since I'm recalculating the minimum spanning tree for each node added, at the start all the nodes have been unconnected, and then I have an empty list for connected. And then what I do here is I just make a starting node, so I just take the first node from unconnected and I push it to connected. And then what I do is I take out that node from unconnected because it's no longer unconnected. And then I check while there are still nodes in the unconnected list, I cycle through all the connected and then all the unconnected, and then you can see the distance is calculated here, and it finds the shortest distance from an unconnected node to a connected node, and then it records the two nodes. Okay, Cloud9 is really glitching. So it records those two nodes that have the shortest distance between them, and then here it draws a line between them, and then it also connects that node that just got connected that was an unconnected node to the connected list. So then this whole loop repeats while there are still unconnected nodes, and the code then finishes. So I can just run my code here. So it runs it at this URL. I can open this URL. Okay, so this black screen appears, so I click to add a node, and then I click again. So it draws a line from that node to this node over here. I can click for another node, and it recalculates it, so I can keep on adding the nodes, and it keeps on calculating the minimum spanning tree for each node that got updated, so I can keep on adding as many nodes. And there is also no cycles in this graph, which is cool, because if there was cycles, that would be wasting or just adding unnecessary weights. So we were last left off, I was displaying how my minimums I'm displaying my minimum spanning tree. So as a final display, I'll just show you three nodes, and I'll make it push this right here. So as you can see, it connects the nodes so that between these two, these are the shortest pairs of edges between the two nodes. So it's not going to push one here, so that would just make a cycle, and that is bad. So you can access my code by this link, which I will have in my description. But there is a chance that this link will not work. And if that is the case, if my code is not currently running, then what I did is I pushed that code to my GitHub, which is just Joe Pari, and under code you can see under visual algorithms, that folder, you'll be brought to this page. So what you can do is you can set up a Cloud9 account and create a new project, and Cloud9 is free. It's a free service. You can create a new project, select HTML, and then just dump these 3 files in there, and then it'll come like this, exactly like this. Then you just click on your index.html, and then on index.html down here you would see a button like this, run. You would click it and it would run under this URL, and then you can access your code. So that is a way you can play around with my code. And if you don't want to do that, then just download the local P5 editor and just copy and paste my code in there, and you should be able to play with it. So that's my video. Just stay tuned to my channel. I'll have future videos. Hopefully that will also come up. And yeah, thanks for watching, and bye.